Now, the big player comes in, the router. This is when you need to pay attention. Host A is sending data over the wire and received by switch A, which looks up its CAM table and assuming interface A's MAC address is already in the CAM table, switch A will send that piece of information out port AR. So, what's the difference, with or without a router? Let's check it out. I'll give you 3 seconds to tell me the difference in the address. Okay, time's up. For those of you who can't answer it, I guess this lesson hasn't been smooth sailing for you. If necessary, please review the video again. But anyway, here's the answer. The destination MAC address has been changed to that of the routers. Why is that? A MAC address only identifies the device within the same subnet. It's like giving you a room number to find when you're in a building. You know the number correlates to one of the rooms in the building. However, if you're in the middle of a highway, a room number will not help you find anything because you don't know the address of the building itself. Therefore, a destination MAC address means router reside in the same subnet as our source, which is host A. And one more thing, a different MAC and IP address, sender or recipient, means the source and destination are located in different subnets. Now information arrives at the router, which strips off the frame encapsulation in order to find out layer 3 information. Router understands that data is coming from interface A and is destined to host B, and assuming that routing information for host B is available. And router's decision is to send the data out interface B, so it will build a new layer 2 header because it strips off the old one and dumped it. Data now make its way to switch B, where it is again checked for CAM entries and send it out port BB. Data is finally picked up by host B and processed. Again, going back to the diagram, we see that data travels from host A's NIC to switch A's port AA, exit at port AR, and arrive at router's interface A. Frame header is rebuilt and exit router at interface B, received by switch B's port BR, going out switch B's port BB, and finally arriving at host B's NIC. While data is moving from interface A to interface B, swapping of the new data link header also trigger another change in the address. As the data is traveling on a different subnet, 192.168.2.0, assuming a /24 mask, the MAC address has to be adjusted correctly. The new source MAC address indicates where it gets the new frame header, which is at the router.